You're listening to Coding Blocks, episode 87. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app. Visit us at codingblocks.net, where you can find show notes, examples, discussion, and more. Check us out. Check us out at Coding Blocks.
That's right. Send your feedback, questions, and comments to comments at codingblocks.net. Follow us on Twitter at codingblocks, or head to www.codingblocks.net and find all our social links there at the top of the page. And Joe has a cold today.
I'm fine. Check us out. I'm Joe Zach.
Oh, man. Yeah, so Joe's out. I'm Alan Underwood.
I'm Joe Zach. And I'm Michael Outlaw.
Oh, man. All right, so as always, we want to get into a little bit of news and thank those that have taken the time to actually leave us some iTunes reviews and Stitcher. So go ahead, Mike. What you got?
Yeah, so from iTunes, we have Detroit++, Joel F., and Artie Chris.
Very nice. And Stitcher, we have AR Heligens. This would not fit with spaces. BMO, Nikora Wesh, and Jakarti. So thank you all that took the time to do that. There were some truly awesome ones in there. The bidet comment.
Oh yeah.
If you have not heard the episode with the bidet conversation towards the end, then you're missing out on some gold there.
Yeah, I gotta agree with BMO on there. He says it's the funniest moment in the history of podcasts, and I think he's right.
It's pretty up there. Oh man, we were talking about it tonight and started laughing. So. Oh, man. All right. So this past weekend, we did get out and do a Coding Blocks community talk with an awesome panel of people. And the topic was Docker and Kubernetes.
Yeah. And so if you go and watch that episode, you'll be able to see, Joe Zach do his Joe Zach impersonation and me do my Joe Zach impersonation. And you can tell us who did it better.
That's right. Yeah, that's right. And so we don't have a link for it yet. It's going to be released probably by the time this episode makes it live this coming weekend. So just head to youtube.com/codingblocks, or if you prefer, you can go to codingblocks.net/YouTube. Either one will take you to our page, and you should see the community talk up there. It was a quite excellent one with Docker and Kubernetes. So if you're interested at all in that, I would say check it out. And the last little bit of news I have here is I somehow got accepted to speak on a topic at Microsoft Ignite in September. I think it's September 24th through 28th or something like
23rd.
that. 23rd through 28th. The date's not set yet. It's supposed to be a podcast type thing, so I don't really know how this thing's going to go down. But if you happen to be at Ignite, come hunt me out. Don't kick me in the shin. I'm not that guy. That's Joe.
Well, unless you're doing a Joe Zach impersonation, in which case,
yeah, I don't want to. I think I'm angrier than Joe Zach, so please don't kick me in the shin. And so that's it for our news. And with that, we're I don't know that we want to call this a lightning round, but we're going to be talking about just several things that we found, right?
Yeah, since Joe couldn't join us tonight, he had a lot going on, and so rather than doing our normal tech-heavy deep dives, we thought we would keep it a little bit lighter, kind of similar to the last one. But since the last one was called Lightning Talks, we were like, "Well, crap! Can we do another
Thunder Talks?
There you go, Thunder Talks, the Garth Brooks other song."
Oh man. I was thinking more along like, what was it? It was AC/DC? Thunder?
Oh, yeah.
Yeah. I was
Thunderstruck.
Okay,
Yeah.
so you've got the country. I've got the old rock. So I guess kicking it off, one thing that's always been really interesting to me, and I think I've even mentioned this YouTube video before, is the JavaScript event loop that happens. And a lot of people just really do not understand how asynchronous and synchronous code in JavaScript works. And if you do anything JavaScript related, whether you're programming in Node.js or you're doing things in a browser for a UI or whatever, it is almost hyper important that you eventually take the time to learn this stuff. So I at least want to scratch the surface of it here. And, hopefully Mike will have some questions or some things that he wants to throw in too, to at least sort of fill this in. So if you're talking about Node.js, they have the V8 engine that they built, and they have these notions of queues and stacks and all that. And your browser also does the same thing. So there is what is called a call stack in JavaScript, and then there's the callback queue. And then if you're talking about a browser, you have this also web API stack. And it's interesting because when you write a function in JavaScript and you just do like a bunch of console.logs in there, what happens is those console.logs will get added to the call stack in the order that they were run. And then basically on every tick, every time that event loop comes back around, it'll take what's next in the call stack, try and run it. And if it's good, then it gets rid of it. And then it goes back to the next tick and it gets the next thing in that call stack and gets rid of it, right? And so in JavaScript, I mean, Mike, you ever seen any code where you did something and the UI just completely hangs up and you eventually get that wait?
That's every application. You say it like I should be surprised.
I mean, if you guys have ever seen that, like in Chrome is like really good about it, right? Like if something sits there and waits for 15 or 20 seconds, it'll be like, it'll send you some ugly picture and be like, something's not working here. You want to just kill the page or you want to wait, right?
It's like, it looks like a broken folder or something. You know,
yeah.
Like dotted out eyes or something.
And if you're seeing that, then basically what's happening is something is actually running, like that call stack, it hit something that is taking a lot of time to finish. And it might be processor intensive, or it might just be a blocking call. It's really hard to say exactly what it is without, talking about some implementation, but that's what's going on. And so really when you're talking about a web page, it really has the one thread that basically everything operates on unless you try to push it off to a background thread. And the way that you typically do that in JavaScript is with a set timeout. And there's new ways to do it now with like the later versions of ES6, ES 2017 now and all that kind of stuff. There's fetch calls and all that. So anytime you're doing like an async call, like to get data, usually that automatically gets kicked off to a separate thread that's not a UI blocking thread. But what happens is, let's say that you do a set timeout, whatever function got passed into that set timeout gets added to a callback queue. So basically, you have this set timeout. Let's say that you do set timeout my function and 1000. So 1000 is 1,000 milliseconds, right? So basically that says, all right, take this thing, and I believe the implementation of this was, it sees that set timeout. It's going to take the function, which I just called it my function, and it's going to put that back in the callback queue. And now in the web API stack over there that your browser manages, it's actually another separate thing. It has a timer over there that it's going to listen for 1,000 milliseconds to elapse. Once that 1,000 milliseconds elapses, then when the event loop picks back up, it's going to go back to that callback queue and say, all right, take this my function call out of the callback queue, move it over to the call stack because this thing's now ready to be operated on. And then what it will do as it goes through that, any code that was in that my function call, those will get added to the call stack and hit in the order. So if I had 5 console.logs in my callback function, then it would put them in the order that they need to be called. And on each one of those event ticks, it's going to run them and then kick them out of the call stack, right? So hopefully what you see now is there's kind of 2 stacks that are working. There's the callback queue that is things that are running, that are sort of sitting in a background thread right now. There's your call stack, which are things that are going to be operated on the next tick, right? As soon as the next tick comes around, then it's going to run the next thing in that stack, and then it's going to kick it off the stack, right? And then there's this web API thing that handles other things like timers or asynchronous calls, things like that. Now,
so basically, you're describing like you could almost think of it as 3 threads.
Sort of.
What you're describing,
sort of, yeah.
Or 3 queues.
They're 3 queues basically, and the thread thing is your callback stack is always going to tie up the UI thread, the main thread of your web app or your Node.js app or whatever that is. That'll always tie it up. So now here's the interesting thing is when you do something like a set timeout 0, if you've ever seen that, basically what you're saying is, okay, I have this function that I want to happen as soon as I have some availability, right? So let's say that you had some method that added 20 different calls into the call stack. And now you call this set timeout 0. Basically what's going to happen is it's going to put that set timeout 0 over into your callback queue. The timer is going to be set at 0, which means that it's really not going to do anything. And then it's going to take that thing out of the callback queue and then put it at the top of the callback stack or at the end of the stack. So basically it's saying don't interrupt everything that needs to happen. If there were 20 items that were about to run, don't try and shove it in there. Wait until those 20 items are done and then do what I need it to do. So that's kind of the way that people have made things happen in a way that won't interrupt the UI thread. Now, here's the thing that's interesting about it. If you've ever seen, like if you just search on Stack Overflow or something on how to do like a timer in JavaScript, typically the answer that you'll see is, just have, like, say that we have a ticker that we use for the show, mm-hmm. right? And I've never looked at the implementation of this, and I don't want to dog on Joe Zack if he did it this way. But the way that this timer works is, it refreshes or shows on the page the new time, the amount of time that it's been running. If you have a page that does a set timeout and then says, hey, go update this screen, right? Basically what happens is after a second, then it's going to go in and try and run this function that tries to update that text on the page. Now, here's the kicker. Just because you say set timeout 1000 does not mean that that is going to happen exactly 1 second later. So think about the situation where you have a long running thread in your call stack that's going to take 20 seconds to complete, right? But then you did a set timeout of 1,000 milliseconds to update your timer. What's going to happen is that thing will, at the end of that 1 second, it'll be pulled out of that callback queue and it'll be pushed onto the callback stack. But if there's something over there running that takes 20 seconds to handle its thing, guess what? It's going to be 20 seconds before your callback is executed. So if you're relying on the set timeout to do like an incremental counter or something, then you could easily get out of sync. Like if you have a bunch of things going on a web page, in this case, our timer, there's nothing on the page except for that. So chances are if it's getting out of sync, it's a tick in the CPU cycles, which is nothing, right? But it's worth knowing about that because a lot of people just take it for granted that, hey, 1,000 milliseconds, this is going to run in a second. No, it's going to run after everything else in that call stack finished, and then it gets to that one.
So one thing, though, that I'm trying to like follow along here is it almost sounds like what you're saying, because when I think of a stack, right, I think of something like, whatever's on the top of the stack gets popped first.
Yep.
Right? And so when you're saying that the callback queue is going to get added to the top of the stack, the callback queue is almost like a way to like get something to pop to the top quick.
So the callback queue, if you think about it like this, if you had a bunch of, let's say that you had a bunch of set timeout 1000s and you just added them all, it would be a FIFO type queue.
First in, first out.
Yep. So basically the same thing that you're thinking about, the first one would go on there, then the second one would go on top of it, third, whatever. And then after that event loop comes around and it finds it, it's going to be like, okay, well, this is the next one that goes over to the call stack. And it'll start taking them out first in, first out.
But
and
the stack would be LIFO though, right?
Last in, first out. So
like the queue would be first in, first out, but stack would be.
It's a first in, first out. It's a first in, first out. So
for the call stack,
for all of them.
Oh, okay.
So I say for all of them, all things being equal, if you had a set timeout of 1,000 and then a set timeout of 2,000, remember what happens. There's a timer that goes in that will then move things into the queue when it's ready, and then move them over to the call stack when they're done. So the cool part is I've got a link to this session stack, which I don't think I'd ever even seen that one before, but they had a really great write-up of how all this stuff works. And then I've got a link to the YouTube video as well, where this guy goes through all of it, and he actually has animation showing, which they do on this other blog post as well. But it's just worth knowing that when you call these set timeouts and all these kind of things, it does put it on a background thread, so it's non-blocking. But at some point, it's going to have to do the work, right? And that's where it's going to hit the call stack. And if you're not handling things in a manner there that doesn't block the thread, then you could also end up with other things. So set timeout was the way to make things happen asynchronously. There are other things like, if you're doing an AJAX call or an async call, those also happen on another thread. What else do I have in here?
Although it seemed like there was a comment that I saw in one of these pages where it was like, you could technically run them synchronously.
You can, and
Never
they say
do
don't.
that.
Yeah, don't. Because so basically what they said is when you call like a fetch, you can actually tell it async false. And the problem is that straight up blocks your UI thread.
Right.
So if you have something that takes 5 seconds to run, you can't do anything on that page at all. And it's probably not doing anything helpful.
Yeah, I mean that's good information because it's certainly in the JavaScript world something I've totally taken for granted. I'm sure. Like I've never bothered to care about how the event loop works in JavaScript.
And that's the thing. Like I guess that's what, if I'd never seen that video a while back, then it probably wouldn't have stuck in my head. But when you start Googling for answers when you're trying to do something, like you have something hanging in your UI thread, everybody's like, "Oh, just do a set timeout," and they treat it like it's a magic bullet. But here's the thing, right? If you do that, if you have a long running thing that happens, you could still potentially block the thread. You're just kind of postponing when it's going to happen by doing set timeouts.
It reminds me of did you ever do any Win32 programming?
Not much.
So I mean, basically, some of the stuff that you were describing kind of reminded me of that world, right? Where like in the Win32 world, there was this main loop that would run, and every time there would be an event, like you could say like, "Oh, that's an event that I want to care about." Otherwise, you would just skip it, right? And that's what it kind of sounds like to me. And so, like by default, you were single threaded, and so you could lock up that thread. But in that Win32 world, the onus was more on you if you wanted to spin up a new thread, whereas in a lot of the language, not just JavaScript, but a lot of the languages that we're in now, it's far easier to spin something off in a separate thread without really putting a lot of thought into it, right? Yep. So like, the whole idea that set timeout's going to go into this callback queue that's on its own clock, versus the call stack, you're not really going to think about it. Just like with the thread pool. I think we've talked about the thread pool before in like a C#, for example, right? Like, you didn't really have to like put a lot of work into it to get the advantage of those threads, right?
Yep. And that actually reminds me of what you just said. So one of the key parts to understand here is if you do something that your system's waiting on. So for instance, I make a call to my backend, right, to get some data, and I do an async call to that. Typically what you do in JavaScript is you pass in a callback, right? Or if you're using promises, same type principle. But what happens is that gets thrown over to the web API stack or thread. And then that thing is going to do its work. And as soon as it gets data back, then it's going to stick the callback in the callback queue, and then it'll get moved over to the stack. So it's just interesting how it kind of moves along the thing so that you're not blocking when you're waiting for things. And there was something else that I found in here that I'd never even heard of. And it's a new ES6 feature, and it's called Jobs. And what they said is and I was trying to read this. I haven't seen any examples of it, but it sounds like it's similar to calling the set timeout 0, basically meaning, hey, run this thing, as soon as you can type deal. Except that it gives you more control over when the jobs run. And I didn't see any details or examples of it, but something that I'll probably dig into at some point and maybe come back with some information on.
Yeah. Or that, or maybe it's just something that they named after Steve.
Possibly.
The Steve Jobs queue.
Yes. Does that mean he's coming back?
It only does one thing, but it does it really well.
There you go. So yeah, that was my first semi deep dive. I think hopefully that gives a little bit of insight into how it's actually doing things in your JavaScript engine and your browser and server environment, whatever's running the JavaScript.
Yeah. So, oh man, I lost my article now. Dang it. Let me see if I can find it again. I had this article that actually Mike RG from our Slack channel shared with us.
Is it Mike RG? I always call him Mike RG. I don't know what it is.
Well, now I'm on the spot. I mean, one,
right,
you're asking the guy who mispronounces every name. So, of course, I would mispronounce Mike, right? It ain't right.
You've only owned it for a couple of years.
Yeah, thanks for driving the bus over me.
Sorry about that.
Okay. So, we were talking about complexity in, several, the algorithm episodes. We had talked about, several algorithms, and we talked about their complexity in regards to time and space complexity. And he sent me this article. Actually, well, he sent it to all of us. It was in the Slack channel. This article that Jeff Atwood wrote, that was really good. It kind of puts things into perspective. And, at some point, I'd like us to do a deeper dive on Big O. But just to kind of quantify some of this, I thought it was really interesting. So Jeff Atwood put together this table where he summarized, there was another guy, Tom Neiman, who put together this table of like what these things would be, right? So depending on the size of your n, what it means to have log n or n log n or n log squared or n factorial. And then Jeff Atwood took it a step further where he adds time to it.
Nice.
So I thought this could be a fun little game to play. So the choices that both of these tables go from for the size of n, they are basically powers of 2, but they skip a lot. So it's going to go 1, 16, 256, 40, 96, and then I'm going to truncate I'm going to abbreviate the rest of the numbers. So 65,000, 1 million, and 16 million. So just know that those are all powers of 2. So when I say 1 million, you know what that is. Okay, so the point that Jeff Atwood was making with this article and why Mike sent it to us is that when we were talking about complexity regarding some of those algorithms is that everything is fast for a small n, okay? So if your n is 1, well then log of n is 0 and n log n is 0 and n squared is 1, n factorial is 1, who cares, right? So in regards to seconds, those would all be less than a second, right? So who cares? So let's see where we get interesting here. Let's say if something is if n is 16. Let's do quantity first, right? So n is 16. N squared off the top of your head? Not fair.
Yeah, I have no
trick
idea.
question.
10 times
right.
16 would be 160. So I don't know.
256.
256. All right.
Okay. So I skipped over log n. I skipped over n log n. We went straight to n squared. N factorial.
Oh man, that's huge. 16 factorial? I have no idea. That's massive.
20.9 trillion. So for n factorial, all right. Now we're not talking about that's just whatever the steps is. Now, so in this table, Jeff says, okay, let's say that each, for sample execution times, assume that each 1 unit of execution time is 1 millisecond of time.
Okay.
Okay. For n16 again, okay, n squared, we said was 256. What do you think that is in terms of time?
That's a quarter of a second.
Okay, well, less than a second, so yes.
Yeah.
Okay, n factorial.
I don't, 2 trillion. I have no idea. That's going to be 2 trillion. You take off 3 zeros, and that gets you in the millions. So that's like 2 million seconds. No, 2 billion seconds. I'm sorry, 2 billion seconds, which I have no idea what that would be in terms of actual minutes.
I'm going to see if you're close. I'm checking your math here. Well, I hate it when it's written in exponents because I never think like that, but I think you're pretty close. 663 years. So if we said that something executed in factorial time, and let's say that your array that you're passing into that function only had 16 elements in it.
Yeah.
It would take 663 years to finish that small array, right?
Not too good.
Okay. So let's skip around to what if it was, where would be a good one? 65,000. No. Yeah, let's do 65,000 in log in.
Okay. So that's going to be, how many times is that? Is it to the 12th power, maybe? 12?
So if we're talking about in terms of the, like what the math would be for that number, then we're at 1 million.
Okay.
Now, this is where the power of the logarithms come in. Because remember we talked about logarithms before and we defined them as like a magnitude, right? So in log n, where n is 65,000, if each one of those units was a millisecond of work, you have an idea?
At 1 million, that's 1,000.
Well, at 60, n is 65,000.
N is 65,000, and we said n log n.
In log n.
If n log n's going to be to like I think that's 12 times 12. Maybe a couple minutes.
17 minutes.
Okay.
So look at how drastic that is, right? For n factorial, where n was 16, we were 663 years. But as soon as we went to a logarithm, we went in log n for 65,000. We dropped down to 17 minutes for it. That's significant. So when we talk about, the complexity of something being in log n versus in factorial, that's huge. And when we describe like that Big O cheat sheet, for example, bigocheatsheet.com, where you can see the graph of these things. And we talk about in factorial being a hockey stick that just shoots almost straight up right away, right? Like that's what we're talking about. Like it doesn't take much for it to go infinite, right? If you go up to...
Well, let's put that in perspective, right? So let's say, so you said 17 minutes if you did n log n. If you just did n time, so this is in milliseconds, so let's divide it by 1,000, and then that's how many seconds?
Well, if it's 65,000 milliseconds, it'd be 6.5 seconds.
Yeah, that can't be right. Hold on.
Why wouldn't it?
No. But n log n would have been way less.
In log n,
just
but it's n times n log n.
N times n log n. Yeah.
Or, I mean, n times log n.
Yeah.
That's what I meant to say.
But I guess what I'm getting at, though, is that would be way faster than n time, I would think, right?
No, n would just be constant. So...
Yeah, so 65,000 milliseconds, so 65 seconds, so I guess a minute.
65? It'd be 6...
Yeah, so 65,000...
6.5 seconds, right? Am I wrong?
65,000.
Maybe I'm wrong. Yeah, no, I'm wrong. You're right.
Yeah, 65 seconds, so it would be a minute and 5 seconds, basically. For it. Okay, so the n log n was actually longer in this case.
Well, yeah, because it's n times the log of n. Yeah.
But if it went way up, like if you did 1 million, then chances are at some point n log n will probably beat n, right? Is I guess what I was getting at.
Well, how could it ever do that?
I don't know.
N would always have to be faster because it's not a multiple. N log n is a multiple, right? Like you're taking n and you're multiplying it by the log of n.
But the log of n is usually really small, I guess is what I'm getting at.
Oh, I see where you're thinking.
Yeah.
You're thinking like if it went less than 0, or not less than 0, less than 1, if it was a fraction, then it would become like a divisor.
Yeah, so basically
Okay.
That's what I was saying is like the 65,000 didn't work, but maybe if you got into the millions or whatever, at some point the log of n is only going to be 20, whereas the n, the constant, is 1 million, right? If you're going after 1 million. So that's what I was getting at is at some point, the whole point of the log of n, which we talked about before, was it's base 2, right? So it's how many times, it's 2 to what power gave you 65,000, right? And
Well, if you're doing base 2, yeah.
If you're doing base 2, which is, I think, what the big O notation uses. And so at some point, as your N scales up, your logarithm will actually beat N time. Even within log N.
Yeah.
I just don't know what that inflection point is.
I mean, I see where you're going with that. It's not going to work out for you like that on this chart.
All right.
So there's your hint. I'm going to give you one last one.
All right.
Let's skip down to the 16 million, and I'll give you your choice. We've talked about in log N. Do we want to do N squared, or do we want to keep it back on in log N just to stay on the same scale as what we've already talked about?
Well, N squared, let's put this into perspective on what that means. That's usually a loop and another loop, right? It would
be a loop within a loop.
Right. It's 2 loops, which is very common in your everyday to-day programming type stuff you see. Yeah, let's go with N squared versus N log N or whatever.
So N squared is going to be in the middle between our N log N and, well, not exactly in the middle. It's going to be somewhere in between, I should say, N log N and N factorial in terms of performance.
Well, of course. Right?
Yeah. Okay. But I'm just letting everybody know, like that,
right.
N squared is still going to be a hockey stick. It's not as much of a hockey stick as N factorial. Okay. So if you have N is, let's say, an array, and N represents the size of that array, and it's 16 million to the power 2, so it's actually more than that, but it's 16 million items in that array. Then
I don't even know how many numbers that's going to be. That's exponent.
So squared, because I don't expect you to know this number off the top of your head, 281.4 trillion.
That's it?
That's 16 million squared.
Okay.
Well, it's like 16.7, blah, 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 blah.
Okay.
Now.
Oh, but factorial is what I was thinking about. Yeah. I'm sorry.
That's
going to be greater than a Google at some point.
I should clarify, too, that when you see this chart, there are parts of it that are just like marked as dash because they're basically like infinite.
Okay.
Like infinite space, infinite time. Like it's not possible,
Never
right?
happened.
So like 16 million for N factorial, forget it.
Yeah.
It's not
big.
happening. All right. So 16 million N squared, where each 1 unit of execution time is 1 millisecond. How long do you think it would take to process that in N squared? Just guess.
That was 25 trillion. Let's go.
No, it was 281.4.
281.4 trillion, and we did 2 trillion. That's 6,000 years.
That's not a bad guess. 8,923 years.
So when the next coming of the dinosaurs are here,
pretty much. So the point is, though, is that really what Jeff Atwood was getting at in this article, though, is that you could look at some piece of code and some algorithm or whatever, and if all you're testing with is small amounts of data, then it's always going to be fast, right? Because no matter how bad you write that code, right, it's going to perform well under a small load, with a small amount of data. So it's important to test things at the scale that you think is realistic to your application.
Yep.
Right? Like the last thing you want to do is to develop something and then wait until you get into a production environment with real customer loads on it and real customer data and the size of real customer data before you realize, like, oh, that thing doesn't perform well at all. Like, for whatever the reason is, right? I mean, there could be a bunch of reasons behind it, but you don't want to do it at that time. So, it's kind of like making me think like, I had this way of summarizing it where it's like, don't confuse load testing with unit testing.
Oh, that's a really good point.
Right? Like those should be treated as 2 separate parts of your process.
What you expect to get out is different than what the performance should be.
Yes.
Yeah.
Yes.
Yeah. I like that.
So, yep. So that was a big thank you to Mike RG.
Man, and you know what? He's actually getting another shout out later in this episode. But we've mentioned it before. If you're not in our Slack channel, like he's in there, he's always dropping awesome nuggets like this everywhere. Like he sprinkles them out throughout all the channels. It's not just general, it's in tips. He puts it everywhere. And he's got some good bourbon choices as well. So, definitely come join us at codingblocks.net/Slack if you haven't done it. All right. So I had a theme for this episode, at least for the first two topics.
Was that supposed to have a theme?
No, probably
I went
not.
Wrong.
So you know what actually started all this is I've been getting back into parallel programming or threaded asynchronous type stuff in my C# world. And that's way more complicated than JavaScript in terms of just having to wrap your mind around what all's going on. And then I was like, you know what? I haven't looked at the JavaScript stuff in a while. So that interest kind of trickled back over here. So did you even know that ECMAScript 2017 is a thing yet? Did you know?
I mean, I think I heard about it I think we mentioned something about it on the last episode, didn't we? I thought maybe I heard someone say something about it.
I don't know, man. So here's the thing. So we've talked about ES 2015, and it was just surprising to me that we've jumped ahead so far already because for years, JavaScript didn't change.
Mm-hmm. I mean, it was like over a dececade, wasn't it?
For like a decade, it was stuck at 4 or whatever it was. And so like now it just seems to just be bolting ahead because people, one of the articles I read said that JavaScript, I believe, is one of the most committed code languages on GitHub right now. So, I mean, yeah, it's just taking off like crazy. So going back to the async stuff that we were talking about earlier and running things on separate threads, I came across this async await in ES 2017, which I was like, well, that looks eerily familiar to some C# that I like. And there's a couple of really good write-ups. There's one on javascript.info/async-await that is really good. And I think they summarize it extremely well. So here's basically, in a nutshell, some of the pieces of this. If you see the word async before the word function, then that means that the function will return a promise. This is using ES 2017. Now, I will say before I get into this a little bit further that I was surprised at how many browsers already support ES 2017. The only one that didn't was IE, which is not surprising. IE hasn't been released in years, right? Edge is the new stuff. So, I was surprised. Now, granted, you have to have certain versions of the browsers for them to support ES 2017, but yeah, all the major ones do. Now, if the function is returning a value rather than a promise, so let's say you have async my function, and then inside there you have return 1, the JavaScript engine itself will actually wrap that thing in a promise and then do a promise.resolve. So it's kind of interesting. It forces it into a promise if you return just a regular value instead of returning a promise from that method or that function.
Wait, say that again. Like normally it would prefer you to return the promise, but if you return back an integer or a Boolean,
it'll put it in a promise.
It'll wrap it for you.
Yes, it'll put the promise around it. So basically, if you think about the way that you do promises, you'd have like you call something and you say .then, it makes it thenable. So if instead of returning the promise that you should have in your method because you had an async function, it will actually wrap it in a promise for you so that you can then do a .then on it. So pretty interesting. Now, very similar to C#, the await keyword can only be used inside an async function. So if you try and use await in something that didn't have async prepending the function name, it's not going to work. And basically, this is very similar to C# again, in that it tells the JavaScript engine to wait until the promise has been resolved for that method that was called. So if I say await, my async function, then it's going to sit there, and if it takes 5 seconds for that thing to finish, it's not going to continue to the next line of code until that's done. However, it's not blocking. Right. It's still running it on a separate thread, but it's not blocking anything. So once the promise is resolved, then JavaScript will pick back up at the next statement. It reminds me of the yield return in C#. So that's kind of cool. Actually, it's very similar to C# in the await there as well.
Yeah, I was
Because
gonna say.
it doesn't block. It literally just lets the thing run, and then it won't go to the next statement until it finishes. And I think it might even use yield. I don't know, behind the scenes. So now here's one thing that's interesting, and this kind of makes sense if you think about it. It says that the await cannot be called directly from the main body of a script. So, if you're trying to do it in the global space of your script, you can't do it because you can only use await inside a function that has been decorated with async. So you can't do that.
That kind of makes sense.
Yeah, it makes sense after you hear it and you look at it. It's like, okay, that's cool. So here's the really cool part. The await works with the existing then and rejects on promises. So it's kind of cool. What
does that mean?
So
I would await. I would dot then.
So if
I would await method dot then.
It's the same as throwing an error. So it's interesting. If you remember, like in a promise, you'd have a promise dot then, and then if you did a comma after your first method in the dot then, your second one was, hey, if it got rejected for some reason, right? You can actually write a little bit, in my opinion, prettier code if you do the await, but you do the await inside a try catch. If it gets rejected, it goes into the catch block. So it's basically then the same as a throw. It throws an error basically. So the rejection is an error. Which, if you think about it, if I remember right, in the promises, there's dot then success, comma error or failure, right? So it's the same type thing. So your await would be you do a try, await. If everything succeeds, fine. Otherwise, go into the catch block if it was rejected.
Still trying to catch up with you there.
So if you think about it, if you had a promise, you might have promise dot then, and in parentheses you'd have on success. That'd be your method call for success, comma on failure would be your method to handle the failure, right? The equivalent using await would be try, open curly, await some method, and then in curly catch, open curly, handle the error, close curly.
So it's almost like you're not doing the resolve response type of promise syntax, or
right,
however you want to call it.
Well, you don't do that second error one. It's handled in your catch statement,
right. Okay.
as opposed to the second method.
So you're saying that you think that's cleaner because it's separating the concerns.
It separates the concerns, and it's also when you start looking at the promises and all those kind of things, like you just have a bunch of like anonymous methods all in one place, right? This to me is a little bit more like terse and easy to see that, oh, okay, I'm going to try and await this thing, and if it fails, then just go into the catch block like most of your other code. So it's not like a special one-off case, I guess.
Okay.
So that's kind of cool. And then so
basically allowing you to have like one catch handler for multiple, like, quote, promises, because you could await multiple times inside of that try.
You could,
and you could have one
catch,
but you could do that with a promise of two, though, right?
You can. It has a fall through. Yeah,
there's like a dot any, I think.
Down at the end, you can actually have it fall through the promises. We covered that extensively in an episode a while back, but yeah. Now,
dot all, I think, is the one I was thinking of, right?
Dot all. So dot all is when everything resolves. Right?
Yeah, everything has to resolve, and if any one of them failed, then it would go into that.
So you can actually do that as well. You can use an await with a promise dot all, and it will continue when all the promises have resolved. So that's pretty cool. Like, you can use it interchangeably with the things that you've been working with promises for a while.
But am I wrong though? That like this, it sounds like the point of this though is to try to move away from
promise dot then
syntax.
Yes.
Like you're trying to make it it's using promises behind the scenes without you needing to worry about that implementation. So while you could do a promise dot all, await promise dot all, maybe you need to.
Maybe not. But here's where things got interesting that this article didn't point out that I found on Mozilla, which, by the way, their JavaScript documentation on mozilla.org is always awesome.
That's the place you go.
It's fantastic.
It's either that or Stack Overflow. That's just the truth. I'm speaking truth.
For the documentation. That's awesome. So So when I was reading through this, I was like, well, let me take a look at this. And they actually had like a big red box on the page. And I was like, danger, Will Robinson, no. So here's what's awesome here is they say, do not confuse await for promise.then. And here's why. And this is where it gets really excellent. So in a nutshell, await tells JavaScript to actually pause until it's done, right? So if you have 3 await calls in a row that each take 3 seconds to complete, it'll be 9 seconds before you reach after that code, right? So await 3-second call, await 3-second call, await 3-second call. It's going to wait 3 seconds for that first one before it goes to the next one. 3 seconds from there to the next one, and 3 seconds and then on, right? So when you call await, it's actually pausing and not going to the next statement in that method or whatever that is until it finishes that first await, right? So if you were to take those 3 calls and you made them a promise.then, they would actually run in parallel. So if you said, for instance, where you had await my 3-second method, instead you said my 3-second method .then, and then you had another my other 3-second method .then, and then my third 3-second method .then.
Okay, so just to be clear, inside of the then, the argument being passed in is my second method.
No. Let's just say there are 3 different methods.
Oh, there's 3 separate lines of code.
3 separate lines of code. I'm just calling them 3 different method names so to keep it clear, so that it's not mixing that up.
Method 1, method 2, method 3.
Right, method 1, 2, and 3. Each one of them take 3 seconds. If you did await method 1, await method 2, and await method 3, it's going to wait 3 seconds for the first one to finish, then 3 seconds for the second, etc. If you do a method 1.then, method 2.then, method 3.then, fires them off in parallel. It doesn't wait for them. It adds them all to something to start operating immediately.
Okay.
And then when those things finish, then you'll get the callback in the .thens.
Well, that was something I was wanting to go back to when you were talking about the await versus the promise.all, right? Because it almost sounded like you could accomplish the same thing in your try-catch, just doing an await for each one of the things, and then with your single catch method, or not, I don't want to call it a method, but your single catch block.
Catch block, right.
Right. But the disadvantage there was what you were saying, because then you're waiting for each one of those and serially to execute. So depending on how long they're going to take, whereas the advantage of the promise.all is that they would run in quasi parallel time.
So it's interesting. Yeah. The part is, if you didn't await on a promise.all, that's almost like doing the promise.all.then, right? That's not really going to change. But when you do await, even though each one of those await calls is running asynchronously, it's going to wait until that finishes before it moves on to the next asynchronous task, right? Whereas if you just do the promise.all, then it's going to run those things all as fast as they can, right? And it's going to do the callbacks as soon as they're available. Now, if you have something that relies, like let's say that, something at the top of your method relies on something further down, or something further down relies on something at the top of the method, that might be a good opportunity to use a wait up at the top, right? So you say, hey, my user equal await go get user. And then further down, you're going to use that user variable to do something. That's a perfectly good reason to do it that way. If you need that user though further down and you just do a promise.then, then you're going to have to start nesting things right inside that .then, because that user is not going to be available until that promise finishes. So it's one of those things that you don't want to wholesale just replace your promises, right? If you have things that you need to run in parallel because they just need to be fast and you don't need the output of them, promise them, right? And just go fire them off. If you need the output of one of those async calls further down in your method signature somewhere, then that's probably a really good point to use await. So there's good uses for it. Don't just, my point here is don't go blanket replace everything with async await. It's a very nice thing. And it allows you not to get into, you remember the callback hell that we called it when you call async things? You can sort of get into that with promises too. If you just keep saying .then, and 20 down, you're there. This allows you to do that cleanly, but you have to know about the trade-offs. So,
All right. Well, how about this one for a JavaScript one? There was another article that I found on Dev2, and I thought it wasn't kind of fair, but I've seen this question before asked, and so I thought like this would still be kind of fun to think about.
All right.
So the premise of the article is and this is going to be in parentheses, so picture like one parentheses block, can A equal 1 and A equal 2 and A equal 3 equal true?
A equal 1. Oh, are we saying ampersand?
I'm sorry. Yes.
Okay.
Maybe I should have made it. Picture this is JavaScript, and you have a statement that says something like if, and then parentheses. I'm not going to say the parentheses again. If A equal 1, ampersand, A equal 2, ampersand, A equal 3.
I know this is a trick question, and I can't think of how that could be true.
Okay. So I've actually seen this before. Now, in the spirit of the article, I kind of, in fairness, didn't like the take that he gave on it. Because basically he was saying like, oh, hey, well, depending on what your font is, there are these like non-printable characters in like this other, language. I don't remember what the dialect was, but, some weird Korean symbol that is basically unseen, but it would be technically before. So what he was saying, his trick to it was that you have this Korean symbol in front of the A, and then you have one of the A's doesn't have the symbol at all, and then the third one has the symbol after the A. So you have symbol A and A symbol. Does that make sense?
Yep, it does.
And I didn't like it because I was like, that's not in the spirit. I've actually seen this once before, and there's a much cooler part of this where you could do it, right? So there were the two top responses to this article where one of them was you could have a value of function on A. So you define A as a constant with the value of function, and anytime you are returning it, you're incrementing some value.
Nice.
Right? So it would read like const A equals value of function, and then you're going to define a function where you say let x equal 1 and return a lambda x plus plus, and then you're going to close out of that because that value of is an iffy, and then your A. So every time you're calling A and it's getting in the underpinnings of JavaScript are getting the value of it, it's going to be incrementing that thing each time. So the first time A is going to be 1, then the next time it's going to be 2, the next time it's going to be 3. And the other one was you define a property on the window for A where the get function of it, you set a global variable, right? And then the get function, so you define a property on the window called A, and the get function of that property would increment the same thing. So both are the same kind of spirit, right? But the first one I thought was a little bit cleaner because you weren't like polluting the global namespace with that variable. But both of them I thought were pretty cool. So since you were like so JavaScript heavy, I thought I would throw that one out there.
That works out, yeah. So was that your second article?
No, that was just a bonus since like your first two were so
very much JavaScript.
Yeah, I thought we would continue having fun with JavaScript and throw that one out there.
I like it. So what's your number 2 then?
Well, I tell you what, why don't we come back to that? Let's say, wait, am I wrong? Yeah. No.
Oh, did you break it up? I didn't even notice it. That is no.
Yeah.
I don't see your other one.
No. Because what we're going to do instead is we're going to say, hey, if you haven't already taken the time to leave us a review, if you wouldn't mind, we greatly appreciate it. And if you have, we super appreciate you. Hopefully, by now how much we appreciate it that you took the time. But yeah, so if you haven't, please do. And by the way, share us with a friend. Spread the word. Tell a friend about the show.
Definitely.
So with that said and out of the way, let's take a moment here. Our last episode survey, we said, what is your favorite book type? So you don't have any competition here. So there's a good chance that you might win this one, Alan.
No, I'm here.
Oh, right. Oh, yeah. You're right. Joe is here.
Right.
So what the question was, what is your favorite book type? And your choices were hardcover. I want to protect my investment. Or paperback. I like to curl the cover back when I read I like to curl the cover back with one hand while I read it. Or ebook. It's the only chance I won't lose it. Or books. Ain't nobody got time for books.
All right. So as Joe, hardcover 31%, and then Alan, I'm going to go. We're not going to get. Joe doesn't want to give any reasons today.
No, go ahead. 31%. Joe says 31%.
Yep. And then Alan, let's go with
Wait, you didn't say which one was. Oh, it's hardcover. 31%.
Yeah, hardcover. He said hardcover. I'm going to go with books. I ain't reading no books, and I'm going to go 30%.
30%. Okay. The funny part about that, though, was that like when you did your impersonation of Joe, and then you immediately went into Alan, there was no difference in the sound. No. This is Joe, and I say 31, and this is Alan, and I say 30.
This is Alan.
All right. Well, somehow you lost to yourself. I don't know how you did that.
I knew it was going to be hardcover. I knew that's what people were going to choose.
No, it was books, but it wasn't 30%.
Oh, really?
No, it was 28%.
On the hardcover? Okay.
No, 28. No books.
Oh,
I ain't got
no books.
I ain't read no books.
I figured.
Yeah, that was 28%.
So
that was the winning.
You know why I thought that? And honestly, I think nowadays people, in the day that we have now, think 10 or 15 years ago when we were developing, the way that you improved is you went and got a book, right? Like that was, unless you had super expensive subscriptions to like MSDN. Nowadays, man, Stack Overflow, YouTube, blogs, like there's so many free resources.
Yeah. Do you remember Media Play?
I do.
Yeah.
They're gone.
They used to be a good source for like programming books.
Man, I remember going to Barnes & Noble and like looking through 20 books, like which one of these $50 behemoths am I buying? Now
you go look in Barnes & Noble in the programming section and it's depressing.
Yeah, they don't, I mean, why would you stock it? People don't buy them as much anymore. So yeah, man, that was my gut. I venture to say most people are just Googling stuff nowadays.
Well,
what was number 2? Hard book?
Ebook.
Really?
Yeah.
People.
It was like just under it. Like just barely under it.
I prefer ebooks, although I hate the formatting of some of those things.
Yes.
They drive it, and some of them you'll click a diagram and it'll just jump you out of your spot in the book. And it's like, what?
Yeah. Or some of them, the diagrams are just like JPEGs that don't render well, depending on like, the Kindle app, for example. Yeah. I'm with you on that. It totally depends. It greatly depends on the type of book I'm reading.
Yeah.
Which we didn't really cover. We didn't qualify that. If it's a technical book, well, let me rephrase that. If it's not a technical book, if it's any other book that's not technical, then I would say I would prefer an ebook.
Same here.
Right? But like what you were getting at, when it's a technical book where you're going to have code listings and you might have diagrams and whatnot, they just tend to not work out so well on, the readers.
It's frustrating. Although, it's funny. I am not a lover of iPads or any just consumption-based device. But one place where I love them is for like ebooks. Mm-hmm. I have a plumbing book that I bought
you do.
But the ebook is awesome because it's color photos and they're high quality and you can zoom in on them and all that kind of, and it's great on an iPad. It's great on anything like that, on a Kindle, on like a Paperwhite.
Oh,
Like, man, I don't even know what I'm looking at here. Right. So,
right.
It kind of depends on the type, but I do love, you'd have to pry my Paperwhite out of my cold dead hands. I love that thing.
Yeah. I mean, for reading something fiction.
Yeah. Fiction. And it's got the backlight. That is why I never owned a Nook or any of those things back in the day. It was because it was like, wait, I got to clip a light to this thing?
Right.
It's a digital thing. Put a light on it.
Right.
As soon as they did that, I was like, I'm in. So,
but that's why I'm more of the opinion that it's like, well, you might as well just get the iPad because it's a better Kindle than most Kindles. So, and it does more than just be a Kindle. So
there's truth, but that thing's tiny, and it's just I don't know, man. It's tiny, and the battery life lasts for months, right?
Yeah, the Paperwhite is like ridiculously light.
I love that thing,
but that's really the only thing it's going to do.
It is.
Yeah. All right. So how about for this survey, we change directions here, and we say, does having multiple monitors improve your productivity? And your choices are absolutely. And on the bright side, get it? I get more work. I get to work on my tan from all the extra UV light.
The more nits, the better.
Or no, but it can be a nice luxury. And lastly, it depends on the code base. The smellier the code, the more monitors I need. That and air fresheners.
All right, so now it's you, right?
No.
You've only done one article.
Oh, well, okay. Well, I mean, I can do another one, but I wasn't in there. But okay. Let's see. Which one do we want to do? Okay, how about this one? We've talked, we get a lot of questions, about like, hey, how do I'm starting out in my career. How do I, get better at it? What's some advice you can help me on getting started? What things like that, right? So the Tech Republic had this article, 10 tips for becoming a better programmer, right? And I've actually got like 2 articles that are going to kind of go hand in hand with this. But first is, I'm going to try to go kind of quick through these 10. But the first is hone your soft skills. And I knew that as soon as I saw that one, I was like, oh, Alan's going to love that. Because you're always talking about like the networking aspect of going to meetups and things like that. Like, it's more than just about what you know sometimes. It's the technical thing. It's more than about the technical things that you know. Number 2, code the real world and code frequently. Meaning just practice and write things. Don't just write like FizzBuzz, right? But like write something real. Number 3, be language agnostic. You don't like that one?
I don't. That's hard. I don't love that one, but well, I get it.
What if we reworded it to say, be a polyglot?
Yeah,
right. Like fair. Know multiple languages, because that's really kind of what they were getting at. Is like learn more than one.
I like not falling in love with one and being only tied to it, right? Like if a problem comes up and it requires Java, do Java. If it's Go, do Go, right? Like right. Don't be in love with it, but yeah.
Don't just write Perl.
Right. Right. Don't.
Poor Perl. Number 4, I know we've talked about this one. Contribute to the open source community. Number 5, join a local user group or mentorship program, which again, going back to our networking thing with meetups, right? Like kind of in that same vein, right? The local user groups, right? Number 6, work on a side project. Now, to me, this one got kind of confusing because I was like, couldn't that really be the same as the open source? Like contributing to open source?
Maybe not. A side project, you don't necessarily want everybody in the world to see it, right? It might be something that you're building that you might want to sell.
I guess where I'm going at is like, it could be the same.
It could be, totally.
It could be the same.
Yeah.
It doesn't have to be. Because You could also like put your own stuff out there in the open source world. And now are you contributing to open source even if you're the only one that's reaping the benefits of that contribution?
You are. Yep.
All right. So here's where you're going to feel better about the being language agnostic. Develop a specialty.
Yeah.
So, pick something and try to specialize on it. It could be a language, maybe, right? But it could be something more than that. It might be something that could span languages, like, machine learning, for example, like just knowing how that works as an example, right? Number 8 is one that I feel like is not exercised enough. Take code review seriously, right? Like be receptive towards constructive criticism and take advantage of your reviewer's experience and time that they're trying to share with you so that you can create something better on your own. Right?
I fully agree with that. And I also think on the flip side of that too, being the person reviewed, accept that feedback and all that, but also as the reviewer, you can learn things, right? You can see new patterns. You can find out about things that you didn't know existed, right? A new feature in the language that you hadn't looked at, whatever. Like it's important both ways.
Here comes your favorite one. Number 9. Learn more about the business side.
All day long.
Yeah. So whatever the software is that you're creating for that organization, be it a profit organization or a non-profit organization, the software that you're writing is empowering a business objective. Maybe not the ultimate business objective that, is mostly responsible for the company. Like maybe you're writing the logging framework for apple.com instead of the next version of iOS or the hardware for iPhone, right? But it's still empowering a business objective.
I agree. You'll never be outside the owner of your company, be invaluable at your job because everybody's replaceable to a certain degree. But if you show that you care about what you're trying to solve, the problem that you're trying to solve, it goes a long way, right? Because then it makes you easier to communicate with, and you'll do a better job because you'll be thinking about what pain am I solving? It's huge. I agree.
And it'll be, going back to our domain-driven design conversations, it'll make it easier for you to have conversations with the business owners, and it'll make it easier for other people to read your code because your code can reflect that same language.
Yep.
Right?
Huge.
So to make conversations easier. Lastly, read voraciously. So yeah, don't just stop your learning at school. Like, I've mentioned before that like college or university is just more about, in my opinion, like a big part of what you're getting out of that is learning how to learn.
Yeah.
Right. When you're young and you're in those early school years, you're just learning how to learn. I mean, you're learning stuff, don't get me wrong, but I think the more valuable lesson is learning how to learn. And you need to continue that and continue practicing that and exercising that, throughout your career.
I agree. And if you're listening to this podcast or any podcast like this, you've already chosen that, right? Like you've picked a profession to where that's kind of what your life is, right?
Yeah, this ain't flipping burgers.
No.
Like this is good. Flipping burgers are going to stay the same for the next 30 years, but I say that and then watch they'll come out with something fancy.
the
Robo flipper.
Yeah. 2020. Oh, yeah, no, it's so true. I mean, this profession is literally, would you say that you learn probably about as much every year? You learn more every year than you did your entire time in college. I venture to say.
I'm constantly picking up books, and I've been in love with Coursera lately. And so I've been taking Coursera courses. Pluralsight, we talk about Pluralsight all the time. That's a great opportunity to learn, and they're not relatively. They're cheap. I would kind of call those like small courses. I forget what Pluralsight actually calls them. They don't call them courses, though, do they?
I don't know.
They call them lessons. I don't remember, but yeah, there's so many great ways to learn out there. And I'm constantly trying to find something because it's more like for me just a fear of like getting behind
becoming
because
irrelevant.
It's so easy, and this industry is always changing so fast, right? So, I feel like, the medical field, you have to stay on top of your game. Legal field, you have to stay on top of your game. Technology field, you have to stay on top of your game. There's some fields where it's probably going to stay about the same for the next 20 years. You might not have to worry about it so much, but man, like those three fields are definitely not. Those are constantly evolving.
Learning's huge. I will say on the soft skills, and I don't think people hit on this enough, and now I'm going to sound like an old man, but you have to be careful about your social profiles, right? Like in I don't want to belabor it or harp on it, but be careful of what you're posting on social media because it can totally change what your opportunities will be. You just have to be careful about that stuff. If you want to write blogs and that stuff about tech, be careful about what you're putting out there because now more than ever, it's who you are and it's how people will look at you and find you and judge you before they even talk to you. So, be careful about that stuff.
Yeah. I mean, there was kind of like a addendum to this that I wanted to add that was more in regards to it's all kind of the same about becoming a better developer, but from a JavaScript point of view, right? Like, how do you keep up in the JavaScript world? Like we've joked about, the framework du jour, right? Like how it seems like it's constantly changing, and it's definitely, in the past few years seemed like it's been more stable, right?
I agree.
You have your big ones, React and Angular, and I guess maybe those might be vying for 1 and 2, and then Vue maybe as a distant third between them. I think that sounds about fair.
Agree.
Not that I'm trying to dog on Vue, but
and are really further back, right? Like there's still some other ones out there.
Yeah,
but
Meteor is somewhere in that equation. But it's just we've joked about how it can be difficult to stay on top of the JavaScript world, right? And so there was another article that had some similar points to this other one. That's why I bring it up at the same time, is that, it's like, well, the other one was talking about like reading and everything. Well, this one was saying like, hey, consume curated content. Let someone else do that for you. So, in the JavaScript world, there are newsletters out there for like JavaScript Weekly, front end newsletter, things like that, a drip of JavaScript. Or there are podcasts out there like JavaScript Jabber is a well-known one. Syntax FM is coming up in the JavaScript ranks. So then there's like they mentioned different learning styles or different sites where you might get your news. So we mentioned Pluralsight, for example, as one place. Udemy is another place that we've mentioned in the past for getting courses. So using those places that are already kind of like curated, lessons that you could use for like whatever it is that you want to stay on top of. But, there's a lot of great content on Dev2 or Medium, for example, a lot of great articles that get put out there.
What do you think about Reddit and Hacker News?
I mean, like
R programming.
Yeah. There's a lot of great stuff that comes up there. The problem that I have with both of those though, is that like, if you're not logged in and you don't save something, or if you don't save it, then you can quickly lose it and you'll never find that again. Right. And you're like, God, what was the name of that article? It was something, it sounded so good. Or maybe you read like, some of the comments in it and then you forgot. Like it can be, that's the only problem I have, is that those filters by so fast, but they do have good stuff. I'm not trying to take any away. And I'm not also, it's not a jab at the other ones that they don't update fast either.
Right. It's just more, those are like a stream of thought almost, like it happens so fast.
Well, those are like drinking from a fountain, from a fire hose.
Right.
It feels like sometimes, but yeah, experiment was listed there. Seek mentorship, which goes back to, the networking, whatnot, learn other languages, expose yourself to others, which, maybe in this day and time, that's the wrong way he shouldn't have phrased it that way.
Right.
But basically
don't do that.
What he was going, yeah, I'm going to reword that for him. Put your content out there, put your code out there and let others see your code.
Yeah, it's much better.
Yeah. He'll thank me later. Basically the idea was like, putting stuff out on Stack Overflow, for example, or going to conferences, speaking at conferences or whatnot, putting articles up on Reddit, things like that, right? And the idea of building stuff and teaching, right? Like teaching is a great opportunity. Like if you think you know something well, try to explain it to someone who doesn't know it. And then that'll only increase your knowledge of it. I mean, yes, you're helping them out, but you're also helping yourself out. So there's a greedy reason for you to try it.
Oh man, the best way to learn is to try and teach.
Yep. Let's see, what were the last ones I had here? I'm going to go through these kind of quick, but contribute to open source, we already covered. Asking questions, and then, yeah. So.
Very nice. All right. So on my last one that I picked up, this one's kind of interesting, and this one's more open. I didn't put a ton of notes here because this is something that we've probably all faced at some point. So it's fake data. And why is it important, right?
The way you wrote that, I assumed that it was a joke, the way you wrote that in the show notes.
Oh, no. So this is something that we've actually faced at our last 2 gigs. And honestly, more and more companies are going to be dealing with this stuff because, I mean, it seems like every time you turn around, there's a data leak somewhere, right? And how much of that is because somebody had cloned the production database and stuck it in a development environment, or they had a copy of their data laying around somewhere because, they needed to do a backup before they ran something. Like, there's just so many reasons that fake data is important, and it sounds really stupid until you start thinking about, okay, well, we need to protect our customers, and we need to protect ourselves from breaches and that kind of stuff. So a lot of times you do need to generate fake data so that your application is usable in a state that makes sense, right? So some of the key points I put down here are, why is fake data important? Okay, well, yeah, you need to see if your system does work, right? Like if there's, if you're going to go use your production version of the application, well, there's certain amounts and types of data in there. Well, you probably need to be able to do the same type thing in your development and your QA environments, but it shouldn't be the real data, especially if it's sensitive data, PII or anything like that. Then you need to create something that's kind of representative of what the population of data in your production environment should be. The other thing is, what if you need to sell your product? You need to demo it. You're going to go demo it with a bunch of real customer data in there and show it in front of a room full of people? Probably not the best move that you could make. So you'll probably need it for there. And
well, I mean, that gets you into all kinds of trouble too, because if it is real data that you're using to demo this product, like whose real data is it?
Right.
Is it data within your own company? Because then you could still have like personally identifiable information that maybe you don't want shown. But, oh man, please don't use some other customer's data to sell to the next customer. That would be even worse.
It'd be bad. I mean, there's just so many bad things that can happen if you're using real data. And the funny part is, I was like, well, how hard can it really be?
Oh,
right?
No, that ain't fair.
I mean, the funny thing is,
to create fake data that looks real.
That's right.
That is, I mean, I don't want to take away from it. You need it. You definitely need to do that exercise, but that is not an easy challenge either.
No, it's not. You actually, if you go about this and you take it seriously, it's a big project to take on, to try. Because here's the thing, and we've seen it, right? It's not just does the data in each individual component look right? It's does all the data together look right? Right? Do the patterns fit? Does the pattern of this data in your development environment and your QA environment match the pattern of data in your production environment, right? Like, it is so much harder than it sounds, and it is such a pain in the butt. That said, this article that I was reading, it was on Medium, which, like Mike said, is a fantastic place to read articles on people that are thinking and working in real world problems. But these guys, there is an application that was created called Fairy. Let me scroll down and find it here. basically what happened is this company had a similar type problem, right? They needed some fake data, but it needed to look pretty good. Here it is, jFairy. And what they did is they created a fake like user data generator, which is fantastic. Let me put it in show notes here because I'm sure that you're probably looking for it. And they actually have a place where you can go up there, you can click around on this thing, and if you go to the GitHub page where they have it, they have a Try jFairy Online, and it's really cool. It generates user information. It generates like identity information, like your personal national identification number, contact information, a credit card, and company information. Obviously, this stuff is all fake, and it's generated, but it all looks very real.
Okay, so the schema behind this is to create a person.
Yeah, kind of a person with their company, their personal contact information, like a credit card or something. Yes, that's what it is.
But I guess where I'm going is it's just that one.
Just that one type of entity with its relationships, right? So if you want to see how hard it might be, they have the source code up on GitHub, and you can come in here and you can take a look. And some of the cool things that they went through with this is like, what's a real credit card look like, right? Like, what's the number? And then we need to validate that kind of stuff. But yeah, I mean, it's pretty neat stuff, man.
Yeah, I mean, because part of the challenge that can come in with that is that, like, if you try to create, okay, it's one thing to create a fake entity or like 1,000 fake entities, right? But where it can get more challenging is you then want to create fake data for each of those entities. So let's say you create 1,000 of these persons from using jFairy, right? And you want each of those persons to have a history of credit card transactions, right?
Right.
And so you want some 1,000 credit card transactions, but you want them to look real. Mm-hmm. And if you were to chart them, you want them to look like they might in the real world, right? Yep. So sporadic and random and whatnot, not a consistent sine wave or something like that, right?
Or sales clumping up near Christmas or holidays or whatever.
Yeah,
like
exactly.
It's a lot of thought processes.
Seasonality.
Right.
So that's where it becomes a challenge. That's where it becomes hard, right? Not just creating the 1,000 persons that, look real.
Yep.
But because you can go out and get activity. The top 1,000 common first names and top 1,000 last names, and do a mix of those, and there's your first name, last name. Now you just got to come up with some addresses. You know what I'm saying? Like,
yep. The interesting thing is in this article they even talk about that, like not taking it a step further and like how that data might exist in your system, like you're talking about, like transactions and stuff. But they even talked about how just even the social security number type thing that they have, this personal number, like you can't just make that up, because if your birth date was here, then your personal number is going to be here, and they need to be able to validate that kind of stuff.
They're going to be in a range.
Yeah, there's going to be a range there. So there's all these things that you have to think about that. Yeah, if you were just trying to do first name, last name, it's probably not that bad. But as soon as you start looking at these further details, like this stuff gets really complicated, just trying to come up with realistic looking fake data. Mm-hmm. So yeah, I thought it was a pretty cool article.
Yeah. I mean, I definitely have had similar conversations where, like, for example, trying to be nice about this. So Redgate is a tool we've talked about in the past, right?
Right.
And I've definitely had conversations with DBA like folks where they're like, oh, well, we can just use the Redgate tools, and because Redgate has a tool where it'll generate a bunch of fake data for the table. Right. And it is a really cool feature, right? And it can, I'm not saying it doesn't have its place, because it does. If you're trying to do queries and whatnot, you just want to be able to test, like, hey, how fast does this thing return back? One of the limitations that it has is that you do have to have what would be the word for it? Your schema needs to be well defined,
right?
With keys and foreign keys in order for it to know that, hey, any data that I create in this table, I expect to link over here too, right? Like, those keys have to exist.
Are you saying that people create databases without all those foreign keys?
Well, I'm just saying, like, if you had a table that had a dependency on, from one to the next, like, yeah, you would have to have that key defined in there.
Otherwise, I wouldn't know.
Yeah, otherwise it's not going to know. And so the data isn't going to necessarily be good. But
so you're saying for basically to spider out and fill in these tables and create the relationships properly, you'd have to have a proper foreign key defined and all that.
But where that tool is going to fail you though is, it's going to look more garbage, like, right? Names versus streets versus, products versus things like that. Like, those are going to start to become like just gibberish. And, again, if all you care about is you're just trying to check the performance of a join or, some kind of query, an index or whatever, you're going after that. Like, hey, how well does this index perform if there's 8 billion records in this table? Then that could be good enough. And it has its place. But the other place where it's going to fail is, like I mentioned a moment ago, is, if you want to then be able to do any kind of statistical analysis on that data where you're looking for patterns in it, right? Like, or you want a pattern in some of the data, like, you mentioned about like the seasonality of credit card transactions and things like that. Like, that's where that's going to, it's not going to have that type of logic built in, right? And how could it? How could it know that you wanted that, right? So you can't expect that.
It's a hard problem to solve, really.
There's definitely a science to being able to create fake data that is fake but looks real, right? So yeah,
and it can be very useful to your application, right? Finding bugs,
so not useful.
And on top of it, it's something that can be reproducible depending on how you do it, right? Which is also a nice thing for developers and testing, integration tests, all that. So yeah, we'll have a link to the article there. It's pretty cool, and like I said, you can go check out the GitHub page and see exactly how they generated this fake user data. And they said it was funny too. When they were going through some of this, it does such a good job that on occasion they hooked it up to Gravatar to see if anything would come in. And on occasion they get a hit, like it would generate somebody that had like a Gravatar email address or something, and they'd come in and they're like, whoa.
Right. Yeah, you're right. No, that actually is another one of the challenges, right? Like creating fake data that is always fake.
Hard to do.
Yeah. All right. So here's going to be a fun one. So the title of this is, now I love Git, right? So you knew that there was going to be a Git one in there. And if you didn't, shame on you. Shame on you. You should have known better. 11 painful Git interview questions you will cry on.
Ooh.
You ready?
Probably not.
Okay. So we'll try to go through these kind of fast because there's 11 of them. But what is Git fork? What is the difference between Git fork, branch, and clone?
Git fork actually creates another copy of the repo that you could merge back in at some point. Git clone is the copy of the same repo. It doesn't like break it off. And what was the other, Git branch? Mm-hmm. Yeah, that's just creating another a branch in the tree that you could merge back into the main repo.
Okay. So the only clarification let's make is that fork is remote, clone is local.
Okay.
Right? And then that way it's, but okay. Yeah, you were like really good. I expect you to know the difference between a pull request and a branch.
Yeah.
Yeah.
Do those a little bit.
This one felt more like for those who were just getting started with Git, but maybe still a helpful one to cover. The difference between Git pull and Git fetch.
Oh yeah, Git fetch will bring down the latest stuff. Git pull will bring it down and merge it into the branch.
Right. Git pull does a Git fetch and a Git merge.
Yep.
Right. Git fetch only retrieves it but doesn't bring it in. Now we're going to start getting fun.
Oh no.
How to revert the previous commit.
Man, I hate this stuff. I don't know how to revert it. I always just check out the previous commit and then act like the other one didn't happen.
Oh, really?
Yeah.
Oh. Well, there's an easier way.
Oh, okay.
Okay. One, you go to Stack Overflow.
Sir, you Google how to revert commit.
Okay. So typically the way I would do it is I would do a git reset -- soft hard ~1.
Okay. Go back one commit.
That goes back, that undoes the previous commit and leaves the changes, still there for you in your index to change, right? You could do the hard one where it would just reset it, right? Like now they're undone. Yeah.
Yep.
And he has another one here for just git reset head ~1. I believe that's the same as soft though, right?
Sounds right. Because if you don't do -- hard, it should make it the soft one, right?
Yeah, that would be the same. Those are the same. -- soft, you could leave it off or add it, but I typically am more explicit. So, what is git cherry pick?
That's bringing in changes usually from a commit hash from one branch into the current branch.
Right. So basically, if you're listening to this and you're like, "Oh man, I don't know," like this is a good list of like things that to be aware of.
And cherry pick's useful. You know what I think we should do in the future, not to derail this? We should talk about the Git workflow that we're using that Microsoft recommends that has actually helped us out tremendously. We should probably do an episode on that. Anyways.
I'm so glad you brought up workflow. Can you explain the advantages of forking workflow?
No.
Okay, so the main advantage, I'm going to paraphrase what he says here, is, or try to keep brief, but the main advantage of the forking workflow is that contributions can be integrated without the need for everyone to push into a single repository.
Okay. Makes sense.
And then once you're done with that, then the developer of that forked repository can make the pull request into the main, when they're ready. All right. Can you tell me the difference between head, working tree, and index?
No. I mean, head is your current saved commit. Working tree, I probably can't give you anything good on that one. And index is where you're pointing in the commit line, and I can't really describe it well.
Okay. So you were in the ballparks for those three. Head is the last commit that's currently checked out in the branch you're in. I should say it's a reference to the last commit in the currently checked out branch. The workspace is just the directory that you're in.
Okay.
That's the current
That's your working tree.
Yeah, wherever, not including your .git directory. I'm not including that one, but that's where all your source is that you can see and edit. And,
okay.
All right. Okay. The index and staging area, that's just a single large binary file underneath your .git directory called index. And it lists all of the files in that branch and their SHA-1 checksums.
Oh, nice.
The timestamps and the file name of them.
Didn't know that.
So it is not a copy of them. That's one of the reasons why Git was preferred over things like SVN.
It's faster.
Because there aren't multiple copies. It was just the SHA-1s that you're comparing.
Very nice.
Okay. Git Workflow. Can you explain Git Workflow? You have to be able to
It's been a while. Yeah. Git Workflow was creating branching strategies where you name the branches, and then you didn't cherry pick, you would merge those things up. Like if you had a change to an earlier branch, then you would merge it up to the next branch, whatever. If I remember correctly, it was something like that. Yeah,
you're pretty much, I mean, the main point of the Git workflow is that you'd pretty much have like two long-lived branches, a develop and a master. And your master branch is always available to be pushed to production, or is always production ready. And whatever that might mean for you,
right.
know. And your develop branch is where all your newest stuff is, and you don't merge that branch in to master until everything has been theoretically, everything has been tested and signed off on as being ready for production, and then you would merge that in. So it uses a merge kind of strategy is what you were getting at.
We've tried that one. That one didn't work out so well for us.
We have successfully used that in the past.
It
depends on
multiple concurrent releases that you have to support.
It depends on the product that you're working on. You and I were at a previous environment where
it worked out well.
We were in a continuously deployed environment where if there was a failure, you moved forward, right? Like you didn't roll. We
tended
extremely rarely did we roll back. We would always roll forward. So if there was a bug, you just fix it and roll forward. And in that kind of scenario, the Git workflow can work quite well. Where what you're referring to, where we had problems with it, is if picture Microsoft supporting Windows, and Microsoft doesn't just support one version of Windows. There are multiple versions of Windows that they support concurrently. And so if they needed to release a bug to that, like how would you do that? That's where the Git workflow kind of fell apart, because if you have these multiple versions that you're still supporting, and now you have a bug fix that you need to make in one of those in the middle, and now you got to like roll it back and roll it forward or something weird like that.
Super hard.
That's where you get into like merge hell.
Yeah.
Right.
And we spent a lot of time there. Yeah, that's a good point.
Yeah. All right. When should I use Git stash?
Oh, if you don't want to commit a change, but you need to go work on a different branch or different set of code or something, you Git stash it to kind of tuck it away. Then you can come back to it later.
Yep. Blah, blah, blah. How to remove a file from Git without removing it from your file system.
Git RM file name.
Without.
That doesn't remove it from the file system, right? I think it just takes it out of the cache.
Git RM will remove it.
From the file system?
Will remove it.
Then it's like Git RM no or -- no cache or something like that. I can't remember.
Okay, this one isn't that hard. You're overthinking it. Git reset file name.
That's it?
That will unstage the file.
Oh, unstage the file. Oh. I thought you said take it out of the cache.
Well, it's weird how they worded their question here. They say, how do you want to remove a file from Git without removing it from your file system?
Yeah, that's Git RM.
If you are not careful during a Git add, you will end up adding files you didn't want to commit. So at that point, Git add is going to take unstaged files and stage them. And he says, if you then do a Git RM, it will remove it from the staging area and from the file system.
But it doesn't remove it from the file system. Git RM takes it out of Git, so it doesn't track the file, right? That's what I was getting at. So Git reset will take it out of the staged area, but Git RM just removes it, so Git doesn't care about that file anymore.
The official documentation, the name of it, removes files from the working tree and from the index. So it will remove the file. Git RM will remove the file.
From the working tree.
Remember, the working tree is just the directory you're in.
So, no. Git RM will not remove a file from just your working directory. There's no option to remove a file only from the working tree and yet keep it in the index. Wait,
no. We're not. Yeah, we're not trying to do that.
Sorry.
I'm saying, like, if you do a Git RM, it will remove it from both.
Interesting.
If you only want to remove it from the index, what they're saying here is that, like, you could do that, use Git reset. But I think to be more specific, the way I would really phrase that is if you wanted to unstage the file.
It. Yeah, so that's different.
Then you could do a Git reset.
So what I was thinking of was Git RM cached, -- cache. So if you don't want, so for instance, you added a file to your directory that you didn't want to be in Git. That's what I was thinking of. Remove it from Git. That'd be Git RM -- cached, and then the file name. And then that would say, hey, Git, don't track this file. I don't want this to go into source control, right? So think of if you were crazy enough to leave passwords in plain text on your system, you wouldn't want it there. Mm-hmm. So going back to what your original intent was, right? The stage thing, if you did a Git add dot and it put everything in there and you wanted to get it out, Git reset, and then the file name will bring it back out of the stage.
Yeah, I feel like in your example, though, I still probably wouldn't do the -- cached. you could do a git ignore on that file.
Git ignore, right?
In that particular example.
I've done the git rm cached whenever something got added to the repo that I wanted to make sure got out of it, right?
Yeah.
Because otherwise, even if you put it in the git ignore after it's been added, it'll stay in there, right?
Right. Yeah, that's a good point. All right, so last one. When do you do a rebase versus a merge?
Oh man, I rebase all the time. So, so that's probably not the right answer. If you have not pushed your branch remote, then I say do a rebase. So for instance, if I check out from master and I'm going to do some work, right? And I have 5 commits and I pull master into mine, then any commits that anybody else has done over time is going to be intermixed with mine. And so the rebase will basically say, okay, take all the previous commits that were brought in from the pull and reorder them so that my commits show up in one chunk, right? Okay. All together.
That's more the answer that I would be looking for.
Okay.
Like if this was my 11 painful git interview questions, like that's the answer I would be more looking for, is that the rebase is going to put it, put your commits at the end of the head.
Yeah.
Right.
In order.
Yeah. Whereas if you just merged it in, then it's going to be merged in, intermixed with everything else.
It's impossible.
Whatever branch you're merging into. Yeah. And it becomes really painful to bisect it or
go back and look at the history.
But like you alluded to, you do have to use it sparingly and with caution. Like you have to know when to use it, because if it's something that has been already shared, then that might not be an option. So it does require some thought on your part before using it, right? That I would never advise any team to just automatically make it a part of their workflow if not everyone on the team understood it.
Yeah, I agree with that. And honestly, if you've ever pushed your branch remote and it's been sitting out there for any amount of time, chances are you no longer want to rebase that locally, because if anybody used that branch for any reason, then you're going to screw it up.
Yeah, especially if you're doing shared development on it. That would be
when you do the rebase. Does it create new commit hashes on those? It probably does, right?
It does create new commit.
Okay, and so that's why it screws it up.
That's where it's rewriting history.
Yeah, so the rebase rewrites the history to put it in the order, like we said, nice and neat at the end. The problem is, if you would push that branch up previously, what was hash 123 might now be hash 567. And so if you were to go try that person, if you merged your code in, that person who used that remote branch, they'd get merge conflicts like crazy when they tried to go merge their code in, which is just nasty. It's wrong to do to people.
It's nasty.
It is nasty. Anybody that's ever spent any time dealing with merge conflicts, they hate life.
Okay, so I'm not sure. This one is definitely going to be a visual, so we're not going to do this one long. Okay, but if you are watching on YouTube, you can follow along with this. But I want to figure out like how we can do this. So this is going to be a little test for you here, Alan.
Hey, wait, did I pass the interview? Did I get the job?
Oh, yes. I'm sorry. Yes, you were hired.
All right.
What's minimum wage these days?
That plus one. That's what I got.
There you go. Okay, let's see if this will work. And you tell me when you can see my screen.
Oh.
And let's do that.
Share.
And share that screen. Oh, did that work?
All right, I got some screen sharing going on.
What do you see?
I see 3 boxes with an arrow in the middle.
Okay. So there was this hilarious, and I'm going to include the links to it, but there was this hilarious thread on the R programming subreddit where it was a quiz. And basically the title is AWS has terrible icons. And they're going to send the results to the AWS team. So the quiz is, you're given all of these, you're presenting with all these icons, and you have to say what the icon represents. So you describe it as best you can, and then tell me what you think this icon is.
Okay, so what I see is what appears to be 3 boxes with holes in the middle of them stacked on top of each other with like a play icon in the middle. I have no idea what this represents.
Okay. That would be Lambda.
Oh,
As best as I can find.
man, there's a Lambda symbol for that. Like, that doesn't make sense. Okay, I got nothing.
I didn't say these were going to make sense. That never came into it. I'm sorry if I misled you.
Oh, man. Okay, so this.
I'm going to give you a hint. This is not a shake weight.
That's awesome. Okay, so it looks kind of like a shake weight. If you don't know what that is, congratulations, you win. This is basically like a rectangular 3D rectangle on the top, 3D rectangle on the bottom, and then like a cube in the middle. I have no idea.
This one is Elasticache.
Man, okay. I don't even know. Yeah.
Okay, wait. It's about to get so much better. I don't know how many of these I don't know how many of these you're going to do before you get tired of it, but try to describe that one.
That's like the same thing. That's like the more realistic representation of the shake weight, except these are rounded.
Well, this is like Minecraft rounded.
You know what? This looks like Toadstool from Mario Brothers. Like, I don't know, man. I got nothing.
Database migration service.
Man, they have coders for designers, I think.
I know, right? You tell me if you how many you want to do a couple more?
Yeah, we'll do a couple more.
Oh no, you
I
can't see
win.
that.
I
No,
win.
You can't see that.
It has the answer key.
Try to describe that one.
Okay, so there's a big block of Minecraft land on the bottom, and then a bunch of weird-looking M's on top. I don't have any clue what that could be. None.
Now realize that like every time I give you one of these, I got to go and then look it up and be like, oh God, what was that one?
I have no idea. Like, none of these seem to represent anything other than polygons.
Directory service. I mean, that's kind of the point that they're making here is that like all of these random shapes that, you know, for these icons, and none of them have meaning.
None.
To anyone. Like,
yeah.
Why would you ever pick these? Like,
I can't even figure out why this would be a directory service. Like maybe it looks sort of like a Rolodex. Maybe if you're really stretching here.
Oh my God.
Maybe.
Wow. Until you said it, now I can't unsee it. But you know, that's the thing is that like, I remember years back, you know, one of the things that Apple had paid, I can't remember. It was a woman who, she made like the icons or something for it. Like, and she was like a well-known artist, if I remember the story correct. But, you know, she made these things to like be meaningful, right? These icons to be meaningful. And, you know, you kind of understood like what it does, right? Just by looking at the thing, right?
Mm-hmm.
Like even the street signs, I remember there was another article, maybe I'm confused. Maybe they weren't, because the other one was definitely a woman that did the street signs. They came up with the symbols for like what would be a yield versus a stop and everything, you know, that we kind of now understand is like, you know, that's what that means, right? But like, where did they come up with some of these things? I don't know, man.
I mean, hopefully you're watching the YouTube version of this because these are awful. Like they're pretty bad. Let's do one more. We'll do one more.
All right.
I do like how you can change the width of it up there. Let's see. What do we got here? Let's say this is some sort of statistics thing. That's the only thing I could come up with. It looks like 2 flat pieces of land topped by what looks like some 3D bar charts.
Okay.
Is it stat related?
Oh man, I can't find it.
Analytics of some sort?
Oh man, it fails me.
You can't lose the thing.
I can't.
I feel like I got 1 out of 5.
Oh no, I found it.
Okay.
You would actually like this one, I think. It's kinesis.
Kinesis. I vaguely remember what that is. I don't. What is kinesis? It seems like a big data thing, right? AWS Kinesis. Let me Google it real quick.
You want
streaming data. Okay, yeah.
You want how many more do you want?
Let's do one more.
Um,
because none of these make sense. Like, they're all awful.
Okay. I think this is where I'm just going to have to like show you this thing. Can I just drag this over here? Here we go.
Oh, you got the entire thing.
Which icon does CloudFront have?
Really? Is this multiple choice, really?
This one is.
Let's do the tower with the L-shaped thingy.
Wait, describe it better.
It says the tower with the L-shaped thingy. Oh, you want me to describe it?
Yeah. Describe it so that like people listening.
Okay, so what this thing looks like is a column out in the middle of a room and looking at the corner of the room. Is that it?
Oh man, now I gotta look at my cheat sheet and my cheat sheet's failing me. Dang it. I wasn't prepared for that.
I really don't know. I feel like literally people just had random polygon drawings and then just dropped them with one of their names. You know what, though? This seems wrong. I could have sworn that AWS Lambda actually had the Lambda picture.
Nope.
Really?
Okay, so you picked the top left.
I did.
Okay. And basically you described that as like a corner of a wall with a column in front of that?
Yeah.
Okay, no. It's the middle left. It's the 6 cubes floating in space. So picture you're playing Minecraft and you have 6 disconnected cubes that are just like all hovering in space. That's that one.
This is ridiculous.
Yeah, it's going to get difficult for like people to follow along. But yeah,
you should check out the YouTube video of this one just to see sort of this. It's pretty awful. I mean, I'm almost of the opinion that if you can't come up with something, like if you're ever designing something and you can't come up with anything that makes any sense, then just use the words. You know.
Yeah, something would be better than some of those icons. That's for sure.
Yeah,
so
man.
Yeah, I'll include that. Where did I put that link?
That'll be in the one resource we like. Actually, we have tons of links in this one, but they'll all be kind of interspersed without the notes. So.
That reminds me though too. Like one of the most hilarious comments in the Reddit about it though was that whoever in the company decided that it would be wise for the company to have a Route 53 product and an S3 product should be shot.
They look a little bit the same.
You look at 53 and S3 and you can't tell the difference.
Oh, man. That's awesome. So now it's time for my favorite part of the show, and it's the tip of the week. And in this case, I have 2. So we've talked about design patterns in the past, and I actually thought about bringing some of these up on the articles that we're going to discuss, but I mean, there's just so many of them. Somebody did a really nice job where they went in to ES6 and JavaScript. So I was very JavaScript heavy in this episode. And they went over many of the design patterns that we've talked about over the episodes and showed the JavaScript implementations of those things. And I think if I remember correctly, a lot of those were using ES6 syntax. So you'd use like the class keyword and that kind of stuff. So if you want to see what the abstract factory looks like in JavaScript, here you go. They have it. The builder, factory methods, singletons, etc. So they have a whole bunch of them in here, and it's pretty cool stuff. And it's weird seeing JavaScript that looks like C# code or Java code or whatever, but pretty cool stuff. And then the other one that I wanted to share, I said that Mike RG was going to get another shout out in this show. So he shared this in the Tips and Tricks Slack channel, and it's called layoutit.com, and it's really cool. If you do any kind of work in Bootstrap, or if you're using CSS grids like the the responsive grids. If you come up to layoutit.com and click on one of those things, you can actually drag components into like a drag and drop thing, so that if you want to design a layout without having to actually code all the divs and everything, you could literally go over here for like Bootstrap. You can choose something like, okay, I want a badge, drag it out into the middle there, and it'll drop it in, and then you can actually get the HTML for that.
That is killer.
It's pretty sweet, right? And it looks great. Like when you do it's...
Let me say this a different way. It's a WYSIWYG for using Bootstrap.
Yeah, man. It's really good. So if you're somebody like me that typically just codes your divs and all this, this is actually faster. And you can see it happen. Like you drag it out there and it'll pop it in place really nice. And you can do your grid layouts, all kinds of stuff, right? And it's even got the ability to change the styles there. You can remove them.
Oh, dude, this is so beautiful.
Yeah, it's pretty sick. So very nice tip from Mike up there on Slack, the other Mike. So thank you much for that, and hopefully you guys get something cool out of that.
Oh, I still can't believe this thing is so awesome.
Yeah, somebody did a really good job putting that one together.
Yeah, they did. Jeez. People got too much time on their hands. You ever feel like that?
I do. I feel like I don't have enough time on my hands.
Yeah, but other people, though. I'm talking about other people got too much time on their hands. Wow. Okay, so I'm going to need some help with this one. So my tip of the week, remember I said, I was going to mention some Git stuff in there. So keeping along with that one, my tip of the week is Git.com. So it's hilarious, but basically the author had gotten into some bad situations himself, and there were certain situations where it was like, oh God, how do I get out of this situation? And here was like an easy cheat sheet of some of the commands that he used to help him out with that. So I thought I would share with that because one, it's just hilarious. So just for comedy, comedic relief, comedy relief, I wanted to share it.
Please tell me Git has a magic time machine.
Yes. Yeah. I mean, let me just read like the first paragraph of this. I'm going to have to, some words I'll skip, but he says, Git is hard. Screwing up is easy, and figuring out how to fix your mistakes is explicitive impossible. Git documentation has the chicken and egg problem where you can't search for how to get yourself out of a mess unless you already know the name of the thing you need to know about in order to fix your problem. So here are some bad situations I've gotten myself into and how I eventually got myself out of them in somewhat plain English.
And the thing is, like you said, it's really funny, but honest to God, there are some just gems in here. Mm-hmm. Like this, if you really want to get better at Git, like this is a good way to be entertained and actually learn how to do it.
Yeah. And so then, inspired by Git.com, someone else authored Vim.com. Now, this one is more of just a cheat sheet, so I felt like I should include it because one, well, just for the comedy of them, like, going along with the other one. But, since I had the other cheat sheets last week, I thought like, okay, fine, I'll include this one too.
Oh, I like this cheat sheet. This one's better than most of them.
Well, now don't forget the Rico's cheat sheet that I shared last time.
His was ridiculous, yeah.
Yeah.
So very nice, man.
So, Git.com and Vim.com.
And now we keep our clean lyrics.
Yep, there we go.
Don't hate on us. We're trying to make this work.
All right. So we hope you have enjoyed this episode. Subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. And if you haven't already, be sure to leave us a review. You can find some helpful links at www.codingblocks.net/review.
Yep. While you're up there, check out our show notes, examples, discussions, and more. And we always forget, if you want some stickers, hit us up at codingblocks.net/swag. There's just instructions there on what to do. Send your feedback, questions, and rants to the Slack channel, codingblocks.slack.com. Be sure to follow us on Twitter at CodingBlocks or head over to codingblocks.net, and you will find all of our social links there at the top of the page.